Hello everyone, today we're going to be going over the entire math section from the 2024 to 2025 SHSAT Student Handbook. For those of you that don't know what that is, this is an entire sample test provided to us by the Department of Education, which are the same people that make the SHSAT. So this is supposed to simulate what the actual SHSAT is like. As of 2024, this is the most recent handbook that was released, so this is the most up-to-date practice test that we have so far. We're going to go over all 57 questions, starting with the grid-ins. The grid-in questions are usually 5 questions that are not multiple choice. You have to, come up with your own response and then plug it into these bubble-in sheets. So these are the only 5 questions on the SHSAT that are not multiple choice. So we're going to start with 58, and it says that after the expression above is simplified, what is the coefficient of x expressed as a decimal? So what is a coefficient? A coefficient is any number in front of any variable. So for example, if I have the variable 3y, the coefficient of y is going to be the number in front of it, or 3. If I have the variable 2x, the coefficient is going to be the number in front of it, or 2. So what this question is asking you to do is first simplify the expression after the expression is simplified, so all like terms are combined. What number is in front of x? So let's go ahead and do that. So we have 3/5, and then in parentheses we have 2x plus 5. And then we're subtracting 2x from that. So whenever you have a variable within a parentheses and you have a number outside of that, you need to multiply whatever's inside by whatever's outside. So in other words, you need to distribute it. So let's distribute this 3/5 into the 2x. 3/5 times 2x is going to equal to 6x over 5. And then 3/5 times 5 is going to equal to 15 over 5. And this negative 2x we just slap on the back. Okay? So now that we've expanded or distributed this 3/5, we can just combine like terms. 6x over 15 over 5 turns into 3. It looks less scary that way. And 2x. So the last thing I need to do in order to combine like terms is to subtract 2x from 6/5, okay? Or do 6x over 5 minus 2x. In order for me to do this, I need to make them have the same common denominator. So I'm going to multiply 2x by 5 over 5, and I'm left with 6x over 5 minus 10x over 5. When you do this, you get 4x over 5, and the coefficient here is going to be the number in front of x. So the number in front of x here is actually 4/5, negative 4/5, okay? Now, there's no way of inputting a fraction into the bubble-in sheet. So what you need to do is you need to convert this into a decimal. If you convert negative 4/5 into a decimal, you get negative 0.8, which is going to be the correct answer here. So just remember how to subtract fractions, and remember that whenever there's a fraction in front of the x, whenever x is a part of a fraction, the entire fraction is its coefficient, not just the 4, the entire fraction. Okay, so now we're moving on to number 59. It says 2 number cubes have sides labeled 1 through 6. Both number cubes are rolled. How many different outcomes will have a sum of 6? So a number cube is just a die. Okay, it's literally just a cube with numbers on the side of it, or literally a dice. So 1, 2, 3, 4, 5, and 6. So if you have 2 of these and you roll them at the same time, how many different combinations will have a sum of 6? For example, if you roll die 1 and die 2, if you roll a 1 on die 1, what number do you have to roll on die 2 so that when you add both numbers up, you get 6? Well, you'd have to roll a 5. So if you roll 1 on dice 1 and 5 on dice 2, they'll have a sum of 6. Okay? Now, what if you rolled a 2 on dice 1? That means you have to roll a 4 on dice 2 in order to get 6. Now, what if you roll a 3 on dice 1? You need to roll a 3 on dice 2 in order to get 6. If you roll a 4, you need a 2 in order for them to add up to 6. And finally, if you roll a 5 on die 1, you need to roll a 1 on die 2 in order to get 6. So all in all, there's 1, 2, 3, 4, 5 different scenarios. There's 5 different scenarios where we're left with a sum of 6. So the correct answer here would be 5. Okay? Why did I circle these? I don't know. I should have circled the entire row. So in other words, again, we have 1, 2, 3, 4, and 5 different outcomes. Okay? It's not going to be 10. Why? Because we roll and release the die at the same time. So this is all one action. You're not rolling 1 on die 1 and then 5 on die 2. You're rolling them at the same time, and you're getting 1 and 5, 2 and 4, 3 and 3, 4 and 2 and 5 and 1. Number 60 says that the figure above shows a scale drawing of a garden where 1 centimeter represents 2.5 meters. It's asking you what is the perimeter of the actual garden in meters. Now, don't fall for the trap here, because what a lot of kids are going to do is they're going to add 6 plus 8 plus 13 plus 3. Okay? And then they're going to multiply it by the scale factor. What the test is tricking you here, or how the test is tricking you, is they are excluding the measure of this side and the measure of this side. So this isn't the perimeter. It's actually going to be, I don't know why it's bugging out. Okay, so it's actually going to be 13 centimeters minus 8 centimeters. So this side is going to be 5 cm. And this top side is going to be 3 centimeters minus 6 centimeters, which is equal to 3 centimeters. So the total perimeter is actually going to be 6 plus 8 plus 13 plus 3 plus 5 plus 3. Okay, so that's the entire perimeter in centimeters now. Now, when we add that up, all of this is going to equal to 38 centimeters. Okay, now our answer isn't going to be 38. Why? Because we have a scale here. This is supposed to represent an actual garden, right? No one's garden is going to be 6 centimeters long. That's way too small, right? But at the same time, you can't draw the actual size of the garden on a piece of paper because the piece of paper is too small. So what we do here is we apply a scale. Some unit on our paper here represents some distance in real life. In this case, 1 centimeter on our drawing represents 2.5 meters in real life. So if we have 38 centimeters and one of them represents 2.5 meters, I need to multiply 38 by 2.5 meters, or 2.5 meters per centimeters, and I get that the actual perimeter of the garden is going to be 95 meters. Okay, so always remember what a scale is and how to apply it. Number 61 says that at one location, the temperature increased from negative 7 degrees Fahrenheit to 4 degrees Fahrenheit between 5 a.m. and 9 a.m. By 11 a.m., the temperature was 3.5 times the 9 a.m. temperature. What is the total increase in temperature between 5 a.m. and 11 a.m. in degrees Fahrenheit? So let's just draw a timeline to see what happened here, because there's a lot of different times to referencing. We know that between 5 a.m., which happened all the way in the morning, and between 9 a.m., which let's just say happens here, the temperature increased from negative 7 degrees Fahrenheit all the way to 4 degrees Fahrenheit. Next, it says that by 11 a.m., which is, let's say, over here, the temperature was 3.5 times the 9 a.m. temperature. So it's going to be 3.5 times the 9 a.m. temperature, which was 4. So 3.5 times 4. Then it's asking you what is the total increase in temperature between 5 a.m., so how much did it increase when it was negative 7, and between when it was 3.5 times 4. Okay? So if we do the math, we know that 3.5 times 4 is 14. So on 11 a.m., it's actually 14 degrees Fahrenheit. Okay? It's actually 14 degrees Fahrenheit. So they're asking you, by how much did it have to increase to go from negative 7 degrees to 14 degrees? And the answer here obviously is going to be 21 degrees, right? If you have negative 7 degrees Fahrenheit, you need to first add 7 degrees Fahrenheit, or increase by 7 degrees, in order to get it to 0 degrees Fahrenheit. And then you need to add another 14 degrees to get it to 14 degrees Fahrenheit. So you're increasing by 7, and then you're also increasing by 14. 7 plus 14 is 21, which is why it's the correct answer. In the figure, number 62 says that the figure below is a triangular prism. The lateral sides are rectangles. What is the volume of the figure in cubic inches, right? So here it's something new because they're asking you for the volume of a cubic, or of a triangular prism. Usually they ask you for the volume of a rectangular prism. And the way that you find a rectangular prism volume and a triangular prism volume is pretty much the same. When you take the rectangular prism's volume, all you're doing is you're multiplying width times length, or base times length, times the height, or width times length times height, right? You're taking the area of the bottom side, which is this, and you're multiplying it by however tall it is. So you're adding this area for every single unit of height, okay? And that's how you fill this entire shape in. Now the same thing happens with a triangular prism, except instead of it being width times length, it's going to be our width, which is my base here, times my height, or times the height of that base, times 1/2. In other words, here all you're doing here is you're just finding the area of this triangle right here, and then you're going to have to multiply it by the height, which is 2. So let's do that. I know my base is 4 inches. I know my height, or the height of the triangle, is 8 inches, and I just have to multiply that by 1/2. This is equal to 16. So I know that the area of this base is going to be 16. Now all I need to do is just multiply this 16 by my height, which is 2. 16 times 2 is equal to 32, which is the correct answer here. Moving on to the multiple choice section. So 63 says that this graph shows y, the weight of a pole, of length x. So this is going to show me the relationship between the length of a pole and the weight of the pole. Okay, and it's asking you what is represented by the coordinates 1, 4. So the point 1, 4 says that a 1 foot long pole is 4 ounces or 4 OZ. Okay, so we can automatically eliminate choices C and B. Why C and B? Because a pole that was 4 feet long would have the point 4 comma 16, not 1 comma 4. Okay, then we could eliminate choice B because the y-intercept happens when x is equal to 0. When x is equal to 0, the y-intercept would be 0, right? That's the only time that you're going to find the y-intercept, when the x is equal to 0. Here, x is equal to 1. The x value of this point is equal to 1, not 0, so that's wrong. And choice D would be wrong because the length increases 4 feet for every 1 ounce of weight. Well, does it? It seems like the length increases by 1 foot for every 4 ounces of weight. To get from 8 to 4, you add 4, and when you get from 8 to 4, the x increases by 1. So that leaves you with the correct answer of A. The unit rate is 4 ounces per foot. A unit rate is going to be a rate where one of the units is 1. So here you have 4 ounces per 1 foot. That's a unit rate because you have 1 foot. One of the units here is equal to 1. That's what makes a unit rate a unit rate. In this case, you see that's true because 1 foot of the pole is actually equal to 4 ounces. So this does represent a unit rate. Remember that a unit rate is a rate where one of the units is equal to 1. So here, one of the units, specifically the one with feet, is equal to 1. That's why it's a unit rate. Number 64 says that the number line shows points E, F, G, and H. Which point represents the sum of 2.5 plus negative 4.5? So in this case, you have 2.5 plus minus 4.5, and you need to match that value with the position on the graph. Whenever you have a plus and minus, the minus is always going to overpower the plus. So 2.5 plus negative 4.5 is the same thing as saying 2.5 minus 4.5. That's actually going to equal to negative 2. So now you're looking on this number line for whichever point lies on negative 2. That point is going to be point F, because it's between negative 1 and negative 3. What's between negative 1 and 3? Negative 2. Now we're moving on to number 65. If 9 over 2x is equal to 3y over 8, what is the product of x and y? So the product of x and y is just going to be x and y multiplied. So they're asking you to find x and y. So you also have 9 over 2x is equal to 3y over 8. In this case, what you need to do is you need to cross multiply. The only way that you can get xy is by cross multiplying. Because guess what? What's across from one another? Well, x and y are across from one another. So if I cross multiply this, I'm going to be left with something that has xy in it, which is what I want to solve for. So 2x times 3y is equal to 6xy, and 9 times 8 is equal to 72. Now, the 72 isn't a choice here. Why? Because they're not asking you between the product of 6x and y. They're not asking you for 6xy. They're just asking you for xy. So in order for me to just get xy, I need to divide both sides by 6. And I end up with xy is equal to 12, which is choice C. Moving on to number 66, it says that a dealership is having a sale where all cars have a 12% discount. What is the discounted price of a car that originally cost $15,600? So we're looking for something with a 12% discount. In this case, we're going to have to take, because it's a discount, our answer is going to cost less than the original price. We're going to take off a certain percent from that price. So in this case, we're left with an original price of $15,600, and we're taking away 12%. So that means we have to find 12% of that number, which is actually going to equal to 0.12. Now, when we multiply that together, we know that 12% of 15,600 is equal to 1,837. Is that my answer? No. This is going to be the amount that was actually discounted. So I take the amount discounted and I subtract it from 15,600, and I get that the discounted price is actually 13,728. Number 67 asks us to divide 4 2/3 by 2 1/2. Whenever we're dealing with mixed fractions, you need to turn them into improper fractions. There's no way to do this without turning this into an improper fraction. So what's 4 2/3 as an improper fraction? Well, 4 times 3 is 12, and 12 plus 2 is 14. So this is actually 14 over 3 divided by 5 over 2. You follow the same rule. You multiply the denominator by the whole number, and then you add 1, and that's going to be your numerator. So there's no way to do this without first converting them into improper fractions. Now, remember the rule for when you want to deal with division and fractions. It's keep, change, flip. So you want to keep 14 over 3 as is. You want to change the division sign into the multiplication sign, and you want to flip 5 over 2 into 2 over 5, and you're left with 28 over 15. Do not choose A. A is wrong. A is a trick answer. You need to convert this from an improper fraction back into a proper fraction, which is going to be 1 13 over 15, which is going to be choice B. A lot of students are going to pick choice A because they don't see 28 over 15 and they see 15 over 28, they just assume that they did something wrong. Never assume that. Always assume that you need to convert your improper fraction into a proper fraction or a mixed number, like it is down here. All right, so we're going to move on to number 68. It says that in a sports league, each team has 36 players and 3 coaches. There are also a number of team assistants. The ratio of team assistants to players is 1 over 6. What is the ratio of coaches to assistants? So when we want to solve this, I want to pretty much go and write everything out. We're going to be dealing with ratios here, so it's very important that we write everything we have out, okay? So we know that each team has 36 players and 3 coaches. So the ratio between players and coaches are 3 to 36. All right, this is coach. I spelled that wrong. Here we have coaches. And here we have players. We also know that the ratio of team assistants to players is 1 over 6. So how do I convert 1 over 6 into a ratio? Well, the numerator is going to represent the value, the first thing that was called. So the ratio of team assistants to players. So this 1 is going to represent team assistants. And this 6 is actually going to represent players. So the numerator represents whatever word was said first when describing the ratio, and the denominator is going to represent the number or the word that was said last. So this means that there's 1 assistant for every 6 players. Okay, so I'm just going to add another column here, assistants. So that's just how you read a fraction and convert that into a numerator, or convert that into a ratio, okay? You take the numerator as the thing that was said first, and you take the denominator as the thing that was said last, okay? So first on top, last on bottom. So now we also know that there's going to be 6 players for every 1 assistant. And now they want you to find the ratio of coaches to assistants. Well, my answer isn't going to be 3 to 1, because guess what? I can't convert that now. The only way for me to get the ratio of coaches to assistants when I write my ratio out here is if they share the same middle value. In this case, they do not share the same middle value, right? If 3 coaches constitutes 36 players, I want to know how many assistants also contributes to 36 players. So I want to convert this 6 to 1 into something that has 36 here. So I can actually multiply both of these sides of the ratio by 6, and I'm left with 36 to 6. So when I have 36 players, I have 6 assistants. When I have 36 players, I have 3 coaches. So because this middle value of players is the same, because these two different ratios have the same relationship to players, I can now compare coaches and assistants, right? Because previously, I'm comparing the amount of coaches when there are 36 players, and I'm comparing the amount of assistants when there's only 6 players. So I need to get more players on the field in order to actually figure out how many assistants there should be. So when I get the 36 players on the field, when I get this value and I multiply both sides by 6 to get 36, now I know that when there's 36 players on the field, there's 3 coaches and 6 assistants. So the ratio between a coach and an assistant is actually going to be 3 to 6, right? Now they want you to do this as a fraction. Remember, coaches to assistants. So coaches is the first word that was called out. So you put coaches on top and assistants on bottom because the first word goes into the numerator. So coaches go into the numerator and assistants go into the denominator. So the choice here, or the correct choice here, would be F for 68. Moving on to 69, it says that Lena is building a fence. She will need to dig holes to help support the posts that will hold up the fence. The holes need to have a depth of 3 1/3 feet below the ground, and each post is 10 feet long. What is the height of the part of the post that is above the ground? That's a lot of words here. Pretty much what this is saying is that when she wants to make a fence, she needs to dig holes for posts. So she's going to dig a hole. And the hole that she digs is actually going to be 3 1/3 feet below the ground. So she digs out a pretty good chunk of the soil. Let's just say that this is 3 1/3 feet. Then into that 3 1/3 feet hole, she puts a post, right, or a piece of wood that's going to be 10 feet long. So into this comes a 10-foot long pole from top to bottom. Okay, this entire thing is going to be 10 feet. Okay. So now they're asking you, what is the height of the part of the post that is above the ground? So what part of this post is above the ground? Well, you already know that 3 1/3 of it is underneath it, and you know that 10 feet comes out of that 3 1/3, so you just need to do 10 minus 3 1/3, and you end up getting 6 2/3 feet. So that's going to be the correct answer here. Moving on to number 70, it says that in the equation above, if r is equal to 2, what is the value of p? So You have two different variables here, and they're telling you what one of them is equal to. So just plug in what it's equal to. So if r is equal to 2, just rewrite it with r as 2. So p plus 2 times r. Well, if you know that r is 2, this is the same thing as saying 2 times 2, which is 4. So p plus 2r, or p plus 4, is equal to 2 times p plus 1 plus 1. So p plus 4 is equal to, I need to distribute this 2 inside, so it's equal to 2p plus 2 plus 1. Okay? P plus 4 is equal to 2p plus 3. I want to combine like terms, so I'm subtracting 3 on both sides, and I get p plus 1 is equal to 2p. And I'm just going to subtract p on both sides, and I get that 1 is equal to p. So the correct answer here would actually be choice F. Moving on to number 71, it says that Karen reads at a rate of 60 pages per day. Martha reads 25% more pages per day than Karen. If the two students begin reading a 1,500 page reading assignment on the same day, how many days sooner will Martina complete the assignment than Karen? Okay, so we know they have different rates that they read. Right? One of them reads quicker than the other one. So we know that Karen reads at a rate of 60 pages per day. We know that Martina reads at a rate that's 25% more. So what's 25% more than 60? Well, you need to do 60 times 0.25, okay, which is equal to 15. And that means that she reads at a rate that's 15 more than that 60. So that's 15 pages per day more than 60, or 60 plus 15, which is going to be 75 pages per day. Okay, so we know that Karen reads at 60 pages per day, Martina at 75 pages per day. Now, we know that they both get the same length assignment. They both need to read 1,500 pages. Okay, so if one of them reads 60 pages per day and the other one reads 75 pages per day, how many days is it going to take for either one of them to complete it? Well, for the one that reads 60 pages per day, 1,500 divided by 60 is going to be 25, and 1,500 divided by 75 is going to be 20. So Martina is actually going to finish this 5 days ahead of Karen because she reads at a higher pace. So all you needed to do here is to find their individual rates and then just divide them by the total amount of work that they had. 72 says that Claire is running on a circular track. She has already run 650 meters. Each lap around the track is a distance of 120 meters. Her goal is to run at least 2,500 meters in all. How many more laps does she need to do in order to complete or reach her goal? Okay, so here we have a circular track, and she's running on it. We already know that she already ran 650 meters. And we know that each lap around the track has a distance of 120. So if I start here and I go all the way around my track, I know that I just ran 120 meters. Her goal is to run 2,500 meters in total. So the first thing I'm going to do is I'm going to subtract that 650 that she already ran from her total goal, right? And I'm going to be left with 1,850. So because she already ran 650 meters, she then needs to run an additional 1,850 meters. Okay? So now, if each lap is going to equal to 120 meters, I'm dividing my total distance by the total amount of laps that I need to run. Now, if I divide this, I'm going to get an answer that's roughly equal to 15.4. It's not going to divide evenly, and it's going to be an ugly number with like a remainder, right? It's about 15.41, maybe 15.417, okay? And it goes on, right? Because you don't need to know the exact value here. What you need to know is that in order for her to complete her goal, she runs 15 whole laps. So she goes around and around and around the circle, right? 15 whole times. And then she runs just a tiny bit extra. She just runs a tiny bit extra. She runs 4.17 extra. But in order for her to complete her goal, she needs to run at least 16 laps. She cannot run 15 laps because if she stops at 15 laps, she still has that 4.17 of a lap to go, which means that even though she can stop midway through when she ran 4.17 of that lap, she still needs 16 whole laps to complete her goal. So moving on to number 73, it says that a company with 200 employees grew in size by 25% between 2005 and 2010. The company grew again by 10% between 2010 and 2015. They're asking you, what is the total number of employees in 2015? So let's just draw a timeline to see what happened here. So we know that we start off at 2005, and then we go to 2010, and then we end up in 2015. So we know that a company with 200 employees grew in size by 25% between 2005 and 2010. So we had 200 employees in 2005. Then we grew by 25%. Now, 25% of 200 is going to be 50. So we knew we grew by 50 employees. So we're going to add those 50 new employees to that 200, and we're going to get that we have 250 employees by 2010. Then we know it grew by 10% between 2010 and 2015. So we're not going to find 10% of 200, we're going to find 10% of 250 because that's the population that grew by 10%. So 250 times 10% is 250 times 0.1, which is equal to 25. So then, in addition to that 250, we knew that we increased by another 25 people, which is 275. And now we have 275 people working in that company in total. So now we're going to move on to 74. It says that a bowl contains 12 green candies, 4 yellow candies, and some red candies. We know that the probability of choosing a green candy at random is twice as great as the probability of choosing a red candy at random. What is the probability of choosing yellow candy at random? So we need to know a simple formula that probability is equal to part over whole. So in other words, it's the part or what you want to happen. So it's what you want to happen divided by everything that could happen. So in this case, we have a bowl that contains 12 green candies, 4 yellow candies, and an unknown amount of red candies. Okay? Then we say that the probability of choosing a green candy at random is twice as great as the probability of choosing a red candy. So if I want to choose a green candy from this bowl, okay, we know that we have 12 green candies. So I want to choose 12 candies. But in reality, I can choose 12 green candies or 4 yellow candies or an unknown amount of red candies. So the probability of choosing green is going to be, well, how many green there are. I can choose from 12. I want to choose all 12, divided by 16 plus R, because this is the total amount of candies in the bowl that I can actually choose from. I want to choose these 12, but in reality, I can actually accidentally end up choosing the 4 yellow in addition to the unknown amount of red. So this is the probability of the green candy. And we know that this is twice as great, or 2 times the probability of choosing a red candy at random. So this is equal to 2 times R, which is how many red candies there are and how many I want to choose, over 16 plus R, which is everything that could happen. So, in other words, I have this fraction. I have 12 over 16 plus R is equal to 2R over 16 plus R. So, in this case, I don't even need to cross multiply because I have the same fraction or the same denominators here. I can just look at the numerators. 12 over 16 plus R is equal to 2R over 16 plus R. R has to equal to 6. If R is equal to 6, 2 times 6 is 12, and you're left with 12 over 16 plus R is equal to 12 over 16 plus R. So we know that there's going to be 6 red candies in the bowl. Okay? So now it's pretty easy. They just want they want to find out the probability of choosing a yellow candy. So now that we know that there are 6 red candies, we now know what my whole is. My whole, or everything that I can choose from, are the 12 green, the 4 yellow, and the 6 red. Okay? So I can add all these together, and I have 22 as my whole. There are 22 total possible candies for me to choose from. Everything that could happen, I can choose all 22. When I want to find the probability of the yellow candies, right, I want to choose 4 out of these 22. So that's my probability. Now, don't panic that this isn't an answer choice. You need to simplify it. So 4 over 22 is equal to 2 over 11. Moving on to number 75. It says that a taxi driver recorded a number of fares each day for 1 month. The box plot displays the data, okay? So based on the box plot, which statement of the data, or which statement is a correct interpretation of the data? This is the way that a box plot works. A box plot represents the distribution of data. This hand right here and this hand right here. This is going to be the smallest number in the data set, smallest. And this is going to be the largest number in the data set. What is a data set? A data set is just all of your data. So for example, if you had 2 fares, 3 fares, 4 fares, 32 fares, right? This is a data set. And we're going to represent this as a box plot. So this 2 is going to be the smallest number in the data set. And this 32 is going to be the biggest in the data set. This middle hand right here is going to be the median, or the middle value, and everything else is going to be 25%. So from this line to this line is 25%, from this line to this line is 25, from this line to this line is 25%, and from this line to this line is 25%. all in all, it's equal to 100%. But in between each one of these lines is going to be 25% of the data. So in this case, 25% of the data falls between 2 and 12, 25% falls between 12 and 16, and 25% so on and so forth. So let's interpret this data. The correct interpretation of this data would be D. On about 25% of the day, there were between 12 and 16 fares. Well, let's look at that. If we know that the distance between each line is 25%, yeah, 25% of the data falls between this line and this line, 12 and 16. The IQR, the interquartile range, is going to be the number that's at the beginning of the box. So this is the box. That's why it's called a box plot. So it's the number at the beginning of the box, which is 12, minus the number at the end of the box, which is 24. So that's going to be the range. This is the interquartile. So this would be wrong. The mean of the data, you cannot find out the mean from a box plot. The median of the data is 16. And you can't say that 2 is an outlier. So the only safe assumption you can say here is literally just follow the ranges. The distance between each line is going to be 25. So the distance between this line and this line is 25, and this line is 25. This one says that 25% of the data is going to be between 2 and 16, which is the distance between this box and this line and this line. So that's the only true thing that's here. Number 76 says that Serena was studying the number of water stations for different lengths of races. The table below shows the data that she collected. Which equation represents the relationship between the length of the race, x miles, and the number of water stations, y? So notice how here we have something that kind of looks like the equation of a linear line, right? We have y is equal to mx plus b. Whenever you see y equals to and a table, there's always going to be some sort of relationship between y and x. In this case, we need to figure that out. So the first thing we need to do is solve for m, right? We need to solve for our slope. M, or our slope, is equal to the change in y over the change in x. So it's going to equal to, well, x miles, so this is going to be x, and number of water stations, y, this is going to be y. Let's say 8 minus 2 over 12 minus 3. So that's going to equal to 4 over 9, or 2/3. So y is going to have to equal to 2/3 x, and that's the correct answer. Why didn't I solve for b? Because no other answer choice here had 2/3 x as their slope. So the relationship is that the number of water stations is equal to 2/3 the length of the race. Number 77 said that Centerville will hold a vote whether to build a new park. The town council surveyed a random sample of 200 residents to determine whether they would be in favor of building this park. And the table shows the results of the survey. Okay, so in total, all of these add up to 200 people. Okay. So the mayor estimates that half of the undecided voters will vote in favor of the building. Based on the survey, if the mayor is correct, how many of the 24,100 voters will be in favor of building the park? So here he's taking a sample, and based on that sample, he's making an assumption on the entire population. So here's a simplified version of that. If I choose 10 people at random, and I ask them whether they're in favor of the park, and 5 of them say yes, because I chose these 10 people at random, I can say that, hey, 50% of people will say yes. Which means that if in reality there's 1,000 people, instead of asking all of them whether they want to say yes or no, I ask a small portion of them whether they think yes or no, and then I apply whatever percentage that is to the entire population. So we know that if 50% of my sample said yes, that means that 500 in reality will say yes. He's doing the exact same thing here. He's taking a sample of 200 people, so it's a bit bigger than my sample, and then he's seeing who's agreeing and who's not agreeing. So the first thing I need to do here is to find the percentages of my sample. So we know everything's going to be out of 200, and you want to see how many will be in favor. So automatically, 142 people are automatically in favor of it. And then the mayor predicts that half of the undecided voters will vote in favor. So if there's 20 undecided, half of that is 10, so those 10 are going to vote for that building, which is equal to 152 over 200. Okay? So 152 over 200 is going to equal to the same percent as the total amount of people who are going to vote for it. So I need to first convert this into a percentage that I can then use. I don't know why it's doing that right now. Hold on. Sorry about that, guys. So I need to convert this 152 over 200 into an actual usable number and multiply that by everything else. So 152 divided by 200 is equal to 0.76. This is equal to 0.76. That means that based on this poll, 76% of the entire population. Remember, you take your sample, you find your percentages, and that percentages you apply to your entire population. So in this case, we found our percentage was 76. So 76% of the entire population will vote yes. If my entire population is 24,100, just multiply 24,100 by 0.76%, and you're going to get choice B, which is 18,316. So that's how sampling works. That's how you apply it here. Moving on to number 78, it says that which of these values, or which number shown above, is the greatest. So remember the rule whenever you're dealing with negative numbers. The closer that your negative number is to 0, the greater it is. In other words, the smallest negative number is the biggest. Why is that? Well, think about it this way. What's bigger, a positive number or a negative number? Obviously a positive number. Negative 1 is less than 1, okay? So if 1 is here and negative 1 is here, right? The closer that you get to 0, the bigger in value you get. Because if you have negative 10, well, negative 10 is less than 1. But negative 1 is actually greater than negative 10 because it's closer to that 1. The closer that a negative number is to 0, the bigger it is. Which is why I'm going to eliminate choice F and H automatically. Choices F and H, well, choice F, negative 49, is like all the way over here. Super far away from 0 and super far away from like my 1. Then I'm going to eliminate choice H because I'm dealing with fractions. Fractions are less than 1. So that means that it's even closer to 0 than negative 1 is. They're all the way over here. Now, the greater your denominator is, the smaller your number is. So choice E is going to be the correct answer. Because if you divide negative 1 into 49 pieces, those individual pieces are going to be a lot smaller than if I divide them into 7 pieces. For example, if I have a pizza and I just divide it into 7 slices, so let's say this, and then I do an extra slice here, every person is going to get a bigger slice of pizza or more pizza than if I divide this into 49 different slices again and again and again. The actual amount of pizza that everyone's going to get is going to be really, really small. So 1 over 49 is going to give you a smaller number than 1 over 7. And because it's going to give you a smaller number, that means that that number is going to be closer to 0 and as a result bigger. So number 79 says, what decimal is equivalent to negative 13 divided by 11? So in this case, let's just evaluate that. You know your answer is going to be negative, and let's just do 13 divided by 11. 11 goes into 13 one time. So we're left with 2 as a remainder. Now, can 11 go into 2? Absolutely not. So we add a decimal point here, and that decimal point drops down a 0 automatically. Now, how many times does 11 go into 20? Well, 1 time. So now we multiply 11 times 1, which is 11, and we subtract this and we get 9. Now, can 11 go into 9? No, it can't. So I'm going to drop down another 0 and now turn it into 90. 11 can go into 90. It goes into 90 8 times. 11 times 8 is 88, and you're left back at 2. Can 11 go into 2? No, so you drop down another 0. 11 goes into 20 one time. You're left with 88, and you get 2. You get 8, 1, 8, 1. And it pretty much follows this pattern forever. So the correct answer here is C. Why? Because whenever you divide this, it's going to follow the pattern. It's going to equal to 1.18, and then the next number is going to be 1, and the next one is 8, and the next one is 1, and the next one is 8, and the next one is 1, and the next one is 8. So because it repeats forever, what you need to do is put a bar over the numbers that repeat. So you can't, so choice A is out of the running, and then choice B is out of the running. Choice A is not there because it doesn't even have a bar. This means that this evenly divides into it. No, this repeats forever, so you need to put a bar over the 1.8. Choice B is wrong because 11 divided by 13 is not equal to 1.118. It's equal to 1.181 forever. And then choice D is wrong because it has the order wrong, negative 1.81. No, it's negative 1.18. 1 comes before the 8, and you put a bar over the 1.8 because that's the part that's repeating again and again. Number 80 says each loaf of bread that a baker makes requires 1/5 ounce of salt. How many loaves can be made if 40 ounces of salt are used? So here we know that we have 40 ounces in total, right? And we're dividing it between 1/5 ounces. So we know that one loaf requires 1/5 ounce of salt. If we now have 40 ounces of salt, how many X loaves can we make? So X loaves. Okay, and we could just cross multiply from here. So we have 40 is equal to 1/5 X loaves of bread. So we could either divide both sides by 1/5, which is what I was doing up here, or we can just multiply both sides by 5. So if we multiply both sides by 5, we get that we can make 200 loaves of bread from 1/5, from 40 ounces of salt, okay? So just set up the proportion up here, right? There's a ratio here. One loaf is 1 and 1/5 ounce of salt. This will always be true. So if you scale this up to 40 ounces of salt, it's still going to follow that same relationship, and it's going to correspond with a specific value of loaves. So then just cross multiply with x here. 40 times 1 is 40, and then the rest is right there. And you just solve for x by multiplying 5 by 5 on both sides. Number 81 asks us, what is the value of 1 and 5/7 minus 1 and 6/7 divided by 3 and 4/7 minus 3 and 6/7? Okay? So in this case, because we have the same denominator, and because we're not multiplying or dividing, we can actually work with this mixed fraction. We know that 1 and 5/7 minus 1 and 6/7, well, the 1 and the 1 cancel out to make 0, and we're left with 5/7 minus 6/7, which is going to equal to negative 1/7. Okay? Next, what's happening in the denominator is that we have 3 and 4/7 minus 3 and 6/7. So the two 3's, the two whole numbers, cancel each other out, and I'm left with 4/7 minus 6/7. The only reason I'm doing it like this is because I have common denominators everywhere. Everything is out of 7. So 4/7 minus 6/7 is actually going to equal to 2/7. So my denominator is equal to 2/7, negative 2/7. Because I have a negative on top and negative on bottom, when you divide a negative number by another negative number, your answer is always going to be positive. So choices A and B are automatically eliminated because they're not positive. Now, negative 1/7 over 2/7 is the same thing as saying 1/7 divided by negative 2/7. So follow the keep, change, flip rule. Keep the 1/7, change the division sign into multiplication sign, and flip the negative 7/2. Here you're left with 7/14, which is 1/2, or choice D. Moving on to number 82, it says which number set represents the values of x that satisfy the inequality. So straight off the bat, you can see that you have greater than or equal to signs. And whenever you want to represent an inequality within a number line, a greater than or equal to sign, no matter the direction, is always going to equal to a shaded in dot. 100% of the time, it's going to equal to a shaded in dot. Now, a regular greater than or less than sign without the equal sign is always going to be an unshaded dot. So just by looking at this, I could automatically eliminate choices E, G, and H because all of them have unfilled dots, which leaves us with the correct answer, F. This is the only answer choice with filled in dots. I should have zero unfilled in dots here. Why? Because this means filled in and this means filled in. So both of the inequalities are filled in. I have no signs that look like this. So on my number line, I should have no dots that look like this. Because in the inequality, I only have inequalities that look like this, or symbols that look like that. On my number line, I should only have dots that look like that. Now, let's say that all of them were filled in and you actually had to solve for it. What you would have to do is just combine like terms on both sides, right? And get x on its own. You get negative 5 is greater than or equal to 1 minus 3x, which is less than or equal to 4. Okay, so you'd have to subtract 1 from both sides. And you get negative 6 is less than or equal to 3x, negative 3x, which is less than or equal to 3. And then you just divide both sides by negative 3. Or all sides by negative 3, and you'd have to flip the direction of the sign, so you'd get 2 is greater than or equal to x, which is greater than or equal to negative 1. So x has to be between negative 1 and 2, which is choice F. Number 83 says that 1 sind is equal to 0.75 plunk. How many sinds are equivalent to 8 plunks rounded to the nearest hundredth? So you that once this is a ratio, so 1 sind is always going to equal to 0.75 plunk. Now, how many sinds are equivalent to 8 plunks? So if I have 8 plunk and I have x sinds, how many sinds am I going to have? And well, I need to solve for that. So because I set up my ratio like this with plunk under plunk and sind under sind, I can just cross multiply. So 8 times 1 is 8. So 8 has to equal to 0.75x. So obviously, the only answer that really makes sense here is going to be choice D. Because 8 divided by 0.75x is obviously going to give you an answer that's greater than 8. Why? Because you know that 8 over 1 is going to equal to 8, and 8 over 2 is going to equal to 4. So if you increase the denominator, the greater your denominator is, the less your answer is going to be. But If you go backwards and let's say divide 8 by 0.5, you'll actually get 16. So whenever you're dividing a whole number by a decimal, your answer is actually going to be greater than the whole number you're dividing by. So it can't be A, B, or C because all of these numbers are actually less than 8, when in reality, you're dividing by a number that's a decimal, or a number that's less than 1. And you could have also just done the regular math here and get 10.67. Number 84 asks us to simplify 8 minus 7 plus 2.5x plus 2. The trick here that a lot of students are going to fall for is they're going to forget to distribute. You may be asking me, well, what do you have to distribute? You have to distribute this 1 or this negative 1. Whenever you have a minus in front of a parentheses, there is always going to be an imaginary negative 1 in front of there, which means that in order for me to simplify this, I then need to distribute this negative 1 here. So negative 1 times positive 7 is negative 7. And negative 1 times 2.5x is going to be negative 2.5x. Okay, so 8x minus 2.5x is going to be 5.5x. And negative 7 plus 2 is going to be negative 5. So the correct answer here for 84 would be F. Number 85 says a community center has two 30-member exercise groups. The director recorded the age of each group's members in the box plots. So remember how a box plot works. You know that this whisker and this whisker are going to be the smallest. You know, the smallest number. You know that this whisker and this whisker are going to be the greatest number, or the greatest values in the data set. You know this whisker and this whisker are the median, or the middle value. And you know that everything between the whiskers is 25%. That's 25%. That's 25%. And that's 25%. Okay, so that's just, again, I explained it in the previous question, but that's just another overview of this. So it's asking which statement about the two groups can be verified based on the box plot. A, both groups have at least one member who is exactly 29 years old. Well, let's look at this, right? Here, we know that the greatest value here is 29. So we know that group Q actually has to have a 29-year-old because the whisker ends at 29. Okay? It ends at 29. That means that one person there is 29. But group P, the whisker actually ends around 33, I think. If you just draw a straight line. It ends at 33, yeah. Which means that the greatest person here is 33. Now, choice A would have to be wrong. If group P ended at 29, then yeah, both groups have to have one member that's exactly 29 years old. But because group P doesn't end at 33, we can't say that. We know that 25% of the data falls between 27 and 33. That does not mean that 25% of the data is 27, 28, 29, 30, 31, 32, 33. That means that 25% of the data is somewhere between this. So it is impossible for us to confirm that both groups have at least one 29-year-old unless both of them ended at 29. Okay, so that's wrong. B says that group P has more members who are at least 17 years old than group Q has. Well, let's look at this. Group P has more members who are at least 17 years old than group Q has. So what are we trying to say here? We're trying to say that group P has more 17-year-olds. Well, we know that the smallest value or the smallest number in group P is 17. Okay? Then we know that in group Q, the smallest number that is present in group Q is going to be 15, right? So group P actually has older people. Why? Because the youngest person in group P is 17, while the youngest person in group Q is actually 15, okay? So group Q, it's possible for them to have a 15-year-old. We know they have a 15-year-old. We also know it's possible for them to have a 16-year-old, and we also know that they have a 17-year-old. So there are two possibilities, or there are two instances when you have a 15 and a 16-year-old in the group. Group P, the smallest person or the youngest person in that group is 17. Then we have a possibility that we have an 18-year-old and a 19-year-old, right? Which means that group P does have more members that are at least 17 years old. Because group Q for sure has someone that's 15, we know that group P has older people because the youngest age there is 17. The youngest possible age in group Q is both 15 and 16 because 16 also falls between this whisker. So I hope this explanation does actually clear this up. So what I'm trying to say here is that if this whisker is the smallest value here, the smallest value of age is the same thing as saying the youngest. So the youngest someone is in group P is 17. The youngest that someone is in group Q is 15. So that means that group P needs to have more members that are at least 17 years old because they have no one that is younger than 17. They need to have more than group Q, because group Q has someone who's 15 years old. So group P could have like 17, 18, 19, 20, right? Group Q, however, has like 15, 16, 17, 19, and 20, just for example. We know that the 17 is true and the 15 is true, right? But because there's a possibility for group Q to have a 15 and a 16-year-old and then have a 17 plus, we know that group P has older people on average, or more members that are at least 17 years old. Number 86 that says that jar Q contains 12 balls and jar R contains 8 balls. The probability of drawing a yellow ball at random from jar Q is 1/3. The probability of drawing a yellow ball at random from jar R is 3/4. If all of the balls are poured into an empty jar, jar S, what is the probability of drawing a yellow ball at random from jar S? So let's look at the difference between the two jars. Here we have jar Q, and here we have jar R. We know that jar Q has 12 balls. We know that jar R has 8 balls. So the probability of drawing a yellow ball at random from jar Q is 1/3. So the probability is 1/3. Now, does this mean that there's one yellow ball and 3 total balls? No, that just means that my probability simplified into 1/3. In reality, I actually have 12 as my whole and x as my part. So if you just solve for this, you know that x has to equal to 4. So in jar Q, there are 4 yellow balls. The probability is 4 yellow. There's 4 yellow balls that I want to choose from, divided by 12 total balls, or 12 total things that could happen. And this probability just simplifies into 1/3. So we know that this has 4 yellow balls. Now we have to do the same for jar R. If the probability is 3/4 in jar R, right? This isn't the actual probability. This is the probability, but this isn't the actual amount of 3 and 4, right? There's not actually 3 yellow balls and 4 balls. In total, there are actually 8 balls. So my whole has to be 8, and this is a simplified version of 6/8, right? So I just multiply both sides by 2/2 to get that denominator. So we know that here we have 6 yellow balls. Now it says that both of these are then poured into an empty jar called jar S. So we combine the 12 balls from Q and the 8 balls from R to get 20 in total. And then in the numerator, we have the probability of drawing a yellow ball, or the 4 yellow balls that were dropped in from jar R, and the 6 yellow balls that were dropped in from jar Q, or the other way around. So here we have 4 plus 6, or 10/20. So 10/20 is equal to 1/2, so that's going to be our probability for number 86. Moving on to number 87, it says that Gia and her friends counted the numbers of pretzels and raisins in their snack mix. The table above shows the numbers in Gia's mix, which other mix has a ratio of pretzels to raisins that is the same proportional relationship as Gia's mix. So right here, we have 12 pretzels and 9 raisins. We can simplify that into something else, right? We can just write that as 12/9. Remember that a ratio can be represented as a fraction, or 12/9, or 12/9. We know that we can simplify this by dividing both sides by 3 to get 4/3, or 4 pretzels for every 3 raisins. So let's see what else simplifies into 4/3. Well, this simplifies into 1/3, which is not the same thing. Choice B simplifies into 5/4, which is not the same thing. Choice C simplifies into 6/5, which is not the same number. And choice D, if you divide both sides by 4, or just treat this as a fraction, this actually simplifies into 4/3. Now, didn't we simplify this into 4/3? And that into 4/3? That means that Trevon's mix has to actually be the correct answer here, because it follows the same proportion, right? 4 pretzels for every 3 raisins. Or it simplifies into the same number or the same fraction as that. Number 88 says that if y is equal to 4x, what is the value of 3y plus 2 times 3y plus 5 minus x in terms of x? So again, this is another type of question that has 2 different types of variables, and we know what one of those variables is equal to. So just plug in 4x for y. If 3y is the same thing as saying 3 times y, and we know that y is equal to 4x, this is the same thing as saying 3 times 4x, or 12x. We have 12x, I'm going to erase that. We have 12x plus 2 times 3y, which we know is, again, 12x, plus 5 minus x. I need to distribute the 2, so we have 2x plus 24x plus 10 minus x. So 12x plus 24x is going to be 36x, minus x is going to be 35. So we're left with 35x plus 10, which is going to be choice G. Number 89 says that the 2 circular plates have the dimensions shown. what is the difference between the areas of the two plates? So we know that area is equal to pi r squared. However, these are not my radii, right? Don't get that confused. These are actually diameters. We know that a diameter is the same thing as saying 2 times the radius, or that radius is equal to just the diameter divided by 2. So the radius of this is going to be 9 inches, and the radius of this is going to be 6 inches. So if a is equal to pi r squared, the area of this one is going to be 81 pi, and the area of this is going to be 36 pi, and the difference is going to have to be 45. Number 90 says that if x is equal to negative 4, what is the sum of x? So what is negative 4 plus 10% of the absolute value of x? Well, the absolute value of x just gives you the positive value of a number. So the absolute value of 4 is just the positive value of 4. You may be saying, well, isn't 4 already positive? Yeah, so you just put 4. Now, the absolute value is handy when you come into negative numbers because the absolute value of negative 4 is going to be 4. It's just the positive version of that value. So it's asking you, what is negative 4 plus 10% of the value of the absolute value of 4, of negative 4? So the absolute value of negative 4 is equal to 4, and 10% of 4 is the same thing as saying 4 times 0.10, or 4 times 10%. Remember that in math, of always means multiply, right? So we have 10% of 4, which is 4 times 0.10, which is 0.4, okay? So what is the value of negative 4 plus 0.4? It's going to be f, negative 3.6. Number 91 says the volume of a cube is 512 cubic centimeters. What is the length in centimeters of one edge of the cube? Okay, so here we know that the area for volume, especially of a cube, is just going to equal to side times side times side. Why? Because in a cube, all of the sides are equal to one another. So this side is equal to it, this side, and this side are all equal to one another. So instead of it being length times width times height, because they're all the same value, it's s times s times s, or s cubed. So we know that s cubed is equal to 512. So which one of these values, when you cube it, is going to equal to 512? Well, it's going to be 8, all right? 8 times 8 times 8. 8 times 8 is 64, and 64 times 8 is equal to 512. You can kind of logic this one out because if you cube 128, that's going to be like a crazy big number. And the same thing with 85 and 42. Those are going to be way too big. Number 92 says that the high temperature on Monday was X degrees Fahrenheit. On Tuesday, the high temperature was 84 degrees Fahrenheit, which was a 5% increase from Monday's high temperature. On Wednesday, the high temperature was 10% lower than it was on Monday. How much lower was the high temperature on Wednesday than the high temperature on Monday? Okay, again, let's just draw a timeline to make this a lot simpler, okay? So the high temperature on Monday was X. So here we have Monday, and we know that the high temperature was X degrees Fahrenheit. Okay? On Tuesday, the high temperature was 84 degrees Fahrenheit. So here we have Tuesday. And here we have 84 degrees Fahrenheit. And we know that this 84 degrees Fahrenheit is a 5% increase. So this is 5% increase from that X. Okay? So we know that if we take X and we multiply it by 0.05 and get 0.05x, or 5% of that, and then add that back to itself, we're going to get 84. Or in other words, 1.05x is going to equal to 84. So if we divide both sides by 1.05, we know that we get 80. This is equal to 80, right? 1.05 divided by 8, 84 is going to equal to 80. So our mystery temperature, we now know to be 80 degrees. Okay? On Wednesday, which is a brand new day on our timeline, okay, on Wednesday, we know that the high temperature was 10% lower than on Monday. So we know that on Wednesday, it's actually going to be 10% lower than the high temperature on Monday. So it's 10% lower than 80. So that's the same thing as saying 80 times 0.10, which is 8 degrees Fahrenheit. So it's going to be 8 degrees Fahrenheit lower, which is choice F. So how much lower was the high temperature on Wednesday than the high temperature on Monday? Well, it's going to be 10% of what we found out Monday was. 10% of 80 is 8. Number 9 says the integers n minus 1, n, and n plus 1 are factors of 168. What is the greatest possible value of n? So in order to do this, we need to actually find out the factors of 168. Now, a quick way to do this would be to just do the prime factorization of 168, right? So we can just divide this and continually split this up into 2. So that's 2 and 84. 84 is going to be equal to 42 times 2, so 2 and 42. 42 is going to equal to 21, or 2 and 21. I'm going to write all my 2's on one side. So 2 and 21, and 21 is equal to 3 and 7. So the prime factorization of 168 is going to equal to 2 times 2 times 2 times 2 times 3 times 7. And the reason why this is important is because if I multiply any of these numbers by each other, it's going to be a factor of 168. So for example, 3 times 7, 21 is going to be a factor. Okay? 3 times 7 times 2, 42 is going to be a factor. 7 times 2, 14 is going to be a factor. Okay? So it's like this that we actually find out those weird factors of 168. So we know that 2 and 3 are a factor. We know that 2 times 2 is 4, so 4 has to be a factor. We know that 2 times 3 is 6, so 6 has to be a factor. We know that 7 is a factor. And if we just keep on going like this, we also know that the next number has to be 2 times 2 times 2, so 8 has to be a factor, right? And now, notice what we have about our integers, right? We have n minus 1, n, and n plus 1. So we have to have a number that's like 1, 2, 3, okay? So 1 is going to be less than n, and then it's going to be n, and 1 is going to be greater than n. So we're looking for that. So right now we have 1, 2, 3, 4, 5, 6, 7, 8, right? Which is really good because we have all of these numbers in consecutive order. The next thing that could be a possible factor is 2 times 2 times 2 times 2, or 4 times 4, which is 16. And here we see that we like begin to lose that nice factorization, or it'll actually be 12, right? The next number would be 12. And here we lose that order. We're no longer going up in 1, 2, 3, 4, 5, 6, 7, 8. The next one after this would actually have to be 14, and then 21. And here you see that the factors stop going up in intervals of 1. So we know that the correct answer here actually has to be 7, okay? Because the greatest consecutive factors of this is going to be 6, 7, and 8. Everything after 6, 7, and 8, 12, 14, and 21 are far too big. They're going to be way too big. And they're no longer apart from one another by a term of 1. So the greatest possible value of n is going to be 7. Because 7 minus 1 is 6. 7 is just equal to 7. And 7 plus 1 is equal to 8. Now 6, 7, 8 appears right here and right here. So the way that I would do this is I would find all of the factors of 168 by using my prime factorization, and I would just multiply these to get different combinations. I'm going to list out those combinations, and I'm going to see what the greatest consecutive numbers are, which is going to be 6, 7, and 8. A is a trick answer. Why? Because 3 minus 1 is 2, 3 is equal to 3, and 3 plus 1 is 4. These are also factors, but they're asking for the greatest values, which is why you can't choose them. Number 94 says that Raul gave 2 musical performances. His second performance occurred 86 days after his first performance. If Raul's second performance was on a Tuesday, on what day of the week was his first performance? So for this number, you need to kind of notice something about dates. Let's just say that I have a calendar that's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, right? And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, okay? So let's say that Monday is the first day of the month, Tuesday is the second day of the month, so on and so forth. If you take any of these days, for example, Tuesday, and you go a week ahead of it, or 7 days in front of Tuesday is going to be another Tuesday. 7 days in front of that Tuesday is still going to be a Tuesday. So if you add 7 to a day, or you go a week from a day, you're going to end up on the exact same day. And the same thing goes if you're going back in time. For example, if you go a week ago from Tuesday, you're still going to end up on a Tuesday. Okay, so that's a very important concept here. Because if Raul's second performance was on a Tuesday, let's just say it was on the 9th, and we're trying to say on what day of a week was his first performance. So we know that it occurred 86 days after his first performance. So this Tuesday is equal to his original day, to his original date, plus 86 days. Okay? So let's see how many weeks back this is. So 86 divided by 7, right? There's 86 days and there's 7 days per week, so that's 1. And that's going to be 2. So we're actually left with 12 weeks with the remainder of 2 days. So we know that 86 days is 12 weeks. So if we go 12 weeks back in time, 12 weeks ago, we still land on a Tuesday. But remember, we still have a remainder of 2 days, which doesn't mean that we're going to go Wednesday, Thursday and choose Thursday. It actually means we're going to go back in time by 2 days. So we're going to go back to Monday, and then we're going to go all the way back to Sunday. So his performance was actually on Sunday. Why? Because we're counting back in time. Whenever you're counting back in time, you're counting in the opposite way. And this would make sense because if you think about this, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, for example. 1, 2, 3, 4, 5, 6, 7. If his first performance was on a Sunday, right? And we know that 86 days passed. 2 days from Sunday is going to be, well, this is 1 day, and this is 2 day. It's going to be Tuesday. So that's the remainder 2. And then we know that there's 12 weeks inside of 86 with the remainder of 2 days. So we go 2 days away from Sunday to get to Tuesday, and then we could just go 12 weeks down to Tuesday. So remember that just because you're going back in time doesn't mean you follow the same order, right? You actually have to go back in time and continue going back 2 days from Tuesday, which is going to be Sunday. That's how you solve this problem. 95 says that Michael received a check for $213 for working 20 hours at his part-time job. The amount of the check was his total pay after $32 in taxes were deducted. What is his hourly rate before taxes were deducted? So we know that in total he made $213, okay? But this is after the government took away 32 of that. So in reality, he actually made $245, okay? So again, when you're getting paid at work, your hourly rate does not account for taxes, right? Taxes are after you're paid your hourly rate. So in this case, you need to divide 245 by 20 in order to get his hourly rate. So 20 goes into 24 one time, and you're left with 45, and 20 goes into 45 two times, so you're left with 40. Subtract it, introduce a decimal because 20 can't go into 5. Now 20 can go into 54 times, and that, two times. And we can stop our math right here because choice C is the only choice that has 12.2 inside of it. So that's the correct answer there. 96 says that, asks us, what is the total surface area in square centimeters of the closed box shown above? So surface area is going to be the area of each side added to one another. So it's the area of this plus the area of this plus the area of this and the area of everything else. So let's just calculate that right now. We know that 20 times 40 is equal to 800. We know that 20 times 50 is equal to 1,000. And we know that 40 times 50 is equal to 2,000. Okay? But this does not mean that there's 3 sides on this box. Remember that there's another side directly opposite of this side. So there's also an 800 there. There's another side that's directly opposite the 1,000. So there's another side there. And there's another side that's directly opposite this 2,000. So there's another side there. So the surface area is actually 1,000 plus 1,000 plus, right, so those are the 2 sides, left and right, plus 800 plus 800, which are the other 2 sides, plus 2,000 plus 2,000, right, which is the top and the bottom. So we're left with 2,000 plus 2,000 plus 2,000, which will be 6,000. Plus 1,600, which is choice G. 97 says that the value of a particular car decreases at a constant rate if the car is worth $15,000 3 years after its original purchase date and $10,000 5 years after its original purchase date. What is the value of the car on its original purchase date? So again, let's just draw a number line or a timeline to help us with this. So we know that, let's say the car was bought on this year. I don't know why it's not working. Okay, it's bought on this year. Then, 3 years after its original purchase date. So let's just say that this is the purchase date. Whoa, this is really not behaving. So this is the purchase date, okay? 3 years from that. So 1, 2, and 3, we know that it was worth $15,000, okay? So that's 3 years after the purchase date. Then we know that it's also equal to $10,000 5 years after original purchase date. So if this is 3 years after the purchase date, this is going to be 4 years, and then this is going to be 5 years. So now it's worth $10,000, okay? So let's notice something here. It decreases at a constant rate, so it's going down by the same amount of money every single time. Now, how do I go from 15,000 to 10,000? Well, I actually go down, or I subtract by $5,000. Well, in how much time? In 2 jumps. So if I decreased by $5,000 in 2 years, that means that I'm decreasing by $2,500 every year. Okay? So over here, I'm decreasing by negative 2,500 once to jump from here to here, and again by another negative $2,500 to jump from there to there. Okay, so now we found out the constant rate at which it decreases by every single year, which means I need to add that number back to go and find the actual value back in time. So we know that between the purchase date and the $15,000, there was 1, 2, 3 jumps or 3 years. So if every jump is equal to $2,500, these 3 jumps is equal to 2,500 times 3, or 7,500. So between the purchase date and the $15,000, it lost $7,000 in value. So let's get that value back by adding it back. $15,000 plus the $7,500 is going to equal to $22,500, which is going to be choice C for 97. Number 98, it said that a bag contains 2 green, 4 blue, and 3 yellow discs. Alana selects 4 discs from the bag at random without replacing them. What is the probability that she selects all 4 blue discs? So we know that the bag has 2 green, 4 blue, and 3 yellow. So 2 green, 4 blue, and 3 yellow. She selects 4 discs from the bag at random, okay? So in total, we're going to be dealing with 2 plus 3 plus 4, or 9. So out of the 9, she removes 4 discs at a time without replacing them. So what is the probability that she selects all 4 blue discs? So when she first reaches her hand in the bag, she feels that there's 9 things inside of that bag. So there's 9 total possibilities that she can choose from. Now, in reality, there are only 4 blue discs that she wants to choose from. So put what you want to happen over everything that could happen. She wants to choose the 4, but she could also choose the 9. So this is my part over whole. So that's the probability of selecting the blue disc at the first time. Now, the probability of selecting the blue disc the second time is actually going to be 3 over 8. Why? Because she doesn't replace it. So when she takes out a blue disc, there's now 3 blue discs in the bag, which means that instead of there being 9 total discs in the bag, there's actually going to be 1 less, which is 3 over 8. And then she selects another disc, which is going to be 2 out of 7, right? Because now she selected the third blue disc, so now there's only 2 blue discs left, and only 7 in the bag. And finally, there's going to be 1 blue disc and 6 discs in the bag, okay? Because you took all of those out. So this is the probability of that entire chain of events happening. Now, this is going to be a lot of numbers to multiply, so make your life easier and cross them out. So pretty much what happened here is whenever you don't replace something, both the numerator and the denominator are going to decrease. So here they're all decreasing by 1 because every single time she's putting her hand and taking it out of the bag, number 1, she's taking 1 blue disc out, and number 2, the total number of blue discs in the bag is also decreasing. Okay? So simplify this. If you have 9 in the denominator and 3 in the numerator, you get 1 and 3, right? If you have 4 in the denominator and 4 in the numerator and 8 in the denominator, you can simplify that into 2 over 4, okay? If you have 2 in the numerator and 6 in the denominator, you can simplify that into 1 over 3. So really, this is the same thing as saying 2 times 1 times 1 times 1 in the numerator, and 3 times 4 times 7 times 3 in the denominator. And when you do that, all that math and all that multiplication, you're actually going to get 1 over 26. So moving on to number 99, it says that Javon earns 0.5% per year on the money in his savings account. Which expression is not another way to write 0.5%? So 0.5% is the same thing as saying 0.5% or 0.005. Okay? Remember that the rule with percentages is you divide it by 100. Okay? That's how you get it. So 0.005 divided by 100 is going to be that represented as a decimal. So that means that choice B has to be correct, right? Choice B has to be correct because that's literally how you convert a percent into a decimal. You divide the percent by 100 in order to turn it into some decimal out of 100, okay? The same thing goes with choice C. 5 divided by 1,000 is equal to 0.005, which is the same thing as that converted percent. 1 over 200, if you divide 1 divided by 200, can 200 go into 1? No. So you put a 0 and a decimal, and then you add a 0 here. Can 200 go into 10? No. So you add a decimal, and you add a decimal, and you add a 0 here. Can 200 go into 100? No. So you added 0 here and another 0 here. Now, can 200 go into 1,000? Yes. How many times? 5 times. So this is also equal to 0.005. which means that choice A is the only answer that's not equivalent to 0.005. This is actually equal to 0.00005, which is far too small. Whenever you're dealing with or dividing by a number with a power of 10, so 1000 or 10 or 100, the rule is you add how many decimal points there are as how many zeros there are. So for example, if you already have 0.5 divided by 100, you're adding how many zeros there are after the decimal point. So this is going to equal to 0.12 zeros and then the 5, because you're adding in whatever's in the denominator. That's the rule. For number 100, it says that a community garden has 50 members in 2001. In each of the next 3 years, the number of members increased by 40% over the number of members from the previous year. So how many members were there in 2004? Okay, let's go ahead and you guessed it, sort this out with a number line or a timeline. We know that we're in the year 2001 and they have 50 members. In each of the next 3 years, the number of members increased by 40% over the numbers from the previous year. So the next 3 years, so 1 year from that is 2002, 1 year from that is 2003, and 1 year from that is 2004. So in total, there are 3 jumps or 4 total years. And we know that the number of members increased by 40% over the number of members in the previous year. So between 2001 and 2003, the number of members increased by 40%. So 40% of 50 is going to be 20. So we actually increased by 20 members, which is going to be equal to 50 plus 20, which is 70. Then we increased by another 40%. Now 40% of 70 is going to be 28. So you actually have 98 members by 2003. And then you continue to multiply these numbers by 40% and add that 40% back. So now you have to do 98 times 40%. And you can't really do that in your head because you have to deal with 2 annoying numbers, right? It's not 90, it's actually 98. There's no 0 here, so you actually have to write out the multiplication. If you write out the multiplication, 98 times 40 is equal to 39.2 members. That's how much it increased by. So then you add that back to the 98. So you know that 98.00 plus 39.20 is equal to 0.27113. So 137.26 members. Now they're asking you to round your answer to the nearest whole number. So you're rounding this to the 7. Because 2 is less than 5, this rounds down into 137 members. So choice H. Number 101 says which inequality is equivalent to 6x minus 20 is less than 5x minus 2 times 5 minus 3x. So this is the exact same thing as if there was an equal sign here. So you need to get x on one side and the numbers on the other side. So treat it like that. Here on this side, we can't combine like terms yet. So we just have 6x minus 20 is less than 5x. And now we have to distribute this negative 2. Do not forget about the negative sign here. This is a negative 2 that we need to distribute. So it's negative 2. And we're distributing it to the 5, which is negative 10, and distributing it to the negative 3. Negative 2 times negative 3x is positive 6x. Okay? So now we can start combining like terms. 6x minus 20 is less than 5x plus 6x, which is going to be 11x. 11x minus 10. Okay? So now we're going to add 10 on both sides. So I get 6x minus 10 is less than 11x. And I'm going to subtract by 6x on both sides. And I get that negative 10x, or just negative 10, is less than 5x. Now if I divide both sides by 5, I get that negative 2 is less than x. So the inequality sign should be facing the x, which is going to be choice 2. Even though choice D is written as x is greater than negative 2, it's the same thing. Why? Because the inequality sign is still facing the x. Choice C is where a lot of students would get confused because they would keep the sign faced this way. The way that the sign doesn't face, the way that the sign faces does not matter. It's what the sign faces. If the sign faces the x, you can rewrite it so long as the sign is facing the x. So here the sign was facing the x, so I can still rewrite it as long as the sign is facing the x just on the other side. Right? Which is why choice D is the correct answer here for number 101. Moving on to 102, it says that a box contains a total of 30 paper clips with colors in the ratio of red, white, and blue, or red to white to blue, and the ratio is 2 to 5 to 3. Okay, so here we have red, or I'll just put the first letter in. So we have R, W, and B. So R, W, B. The ratio is going to be 2 to 5 to 3. Okay, and it's saying that suppose one clip of each color is removed from the box and not replaced, what is the probability that the next paperclip chosen will be blue? So the way to solve for this is first we need to find out how many actual red, white, and blues there are. Because we have a total of 30 paperclips, right? So this is a simplified ratio because 2 plus 5 plus 3 is actually equal to 10, not 30. So you can't say that this ratio actually is consistent of all of the numbers. Again, just like in one of the previous problems, this ratio is simplified, okay? Remember when we had like those 9 raisins to the 12 nuts and we had to simplify this ratio? The ratio was equal to 3 to 4 or something. The same thing is happening here. So we actually need to find out what the original value is like, or how many reds and whites and blues there are originally, which means that we need to figure out how we can turn this 10 into 30. Well, we just multiply it by 3, which means we multiply everything here by 3. Another way you could do this is just put it as 2x plus 5x plus 3x is equal to 30, or your total. You get that 10x is equal to 30, and that x is equal to 3. So the scale factor, or the thing that you need to multiply everything by to get the actual values, is going to be 3. So you multiply 2 by 3 to get 6. You multiply 10 by 3 to get 15. And you multiply 3 by 3 to get 9. So this is the actual ratio of colors within the box, okay? So knowing this is the actual ratio of everything that is within the box, now we can remove one paperclip from each box, or one paperclip from each color. So if we remove one, we now have 5. Again, the colors don't match. We have 5, 14, and 8, okay? So we're left with 5, 14, and 8. Now it's asking us, what is the probability that the next paperclip chosen will be blue? So now we have 27 in total, and we want to see what our chances of getting those 8 blue out of those 27 are. That's going to be 8 out of 27. You want to choose the 8 blue, but in reality, there's 27 from you to choose in total. Number 103 says that the least positive integer evenly divisible by the first positive integers is 60. What does that mean? The least positive integer. So a positive integer is going to be a positive whole number. So nothing with a decimal point. Now remember that 0 is not positive or negative. Why? Because anything after 0 is negative, and everything before 0 is negative, everything after 0 is positive. So how can 0 be positive or negative if it is the border? It's just a border. So 0 kind of serves as a border between the negative domain and the positive domain, okay? So if we're dealing with positive whole numbers and 0 is not positive, that means that we're dealing with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Now it's saying that the least possible integer evenly divisible by the first 6 positive integers is 60. So the first 6 positive integers is 1, 2, 3, 4, 5, 6. We know that 60 is divisible by 1, 2, 3, 4, 5, and 6. It's the smallest number that's divisible by all of them. Now it's asking you, what is the least positive integer evenly divisible by the first 8 positive integers? So if we know that 60 is divisible by all of these, the first 6 positive integers, what number is going to be divisible by the first 8? So the first 8 are going to be 1, 2, 3, 4, 5, 6, 7, and 8. So which one of these numbers is divisible by all of these? Well, first of all, we can eliminate choice D, 420, because 8 does not divide into 42, okay? Here's the thing. This extra 0 does not matter here. This extra 0 just means that when you divide it, you add an extra 0 to whatever your quotient is. So in reality, we're really just looking at 42, 48, 84, and 1,680, or 168, okay? The only reason why it has to be 0 is because of the 5, right? 5 can divide into anything that's 0. So now we just need to see which one of these values contains everything that we can divide into. And the correct answer here was actually going to be choice B, 840. 1 divides into everything, so we're good. 2 divides into everything that with an even end, okay? So 0 is an even number, so that means that 2 divides into it evenly. 3 divides into anything whose numbers add up to a multiple of 3. So in the case of 840, its numbers, or the numbers that comprise the number, are 8, 4, and 0. 8 plus 4 is 12, and 12 plus 0 is 12. 3 divides into 12, which means that it has to divide into 840. 4 divides into 840. 5 divides into anything that ends with 0 or 5, so 5 divides into it. 6 times 12 is equal to 84, okay? or actually no, 7 times 12 is equal to 84. So we know that 7 divides into it evenly. We know that 8 divides into 840 evenly, and the same thing goes with 6, right? So again, you can test it out, but pretty much this is the smallest value that's going to work for everyone. Number 104 says that there's 3 different colors of paint that are available to paint a window frame, the door frame, and the wall of a house. So we have 3 different locations that we can paint. If no 2 parts of the house may be painted by the same color, how many different ways are there to paint 3 parts of the house? So look, we have 3 different colors. Let's say we have red, white, and blue. Okay, so 3 different paints. And we need to paint a window frame, so a frame around a window. We need to paint this thing. Okay. We also need to paint the door, which looks like this. And we also need to paint the wall of a house, which is literally just this. Now, it's saying that if no 2 parts of a house may be painted the same color, so this is the only thing that can be painted red. This is the only thing that can be painted white. And this is the only thing that can be painted blue. How many different possible combos are there? Well, let's say that over here, I have my window, my door, and my wall, okay? My window, my door, and my wall, okay? If I want to paint my window first, I have 3 colors to choose from because I haven't painted anything else yet. I can choose from 3 different things. I can paint my window red, I can paint my window white, I can paint my window blue. Now, when it comes to my door, I can choose from 2 different colors. Why? Because I already painted my window one color. I can't paint all of these things at the same time. I can paint them one after the other. So now, because I painted my window one color, I can only paint my door the 2 remaining colors. And after I paint my door, I can only paint my wall the 1 remaining color after that. So every single time you paint one of these places in your home, you have less and less choices to choose from. So if you want to find the total amount of combinations, you multiply all your possibilities together. So for the first part of the house, you have all possibilities. You can paint with all 3 colors. For the second part of the house, you can only paint with what's left. Meaning that when you use 1 color, you have 2 colors left. So you have 2 left. So it's 3 times 2 times 1, which is equal to 6. For number 105, it says that triangle MNP is similar to triangle XYZ. MN is equal to NP. So MN, NP. Now, a similar triangle is always going to have some conversion factor, meaning that there's some magical number that you can multiply this side to get to this side, or this side to get to this side. In this case, I want to know the magical number for me to multiply this number to turn it into this number. So what do I multiply by 6 in order to get to 10? Well, can I just divide both sides by 6 and figure it out that my question mark is equal to 10 over 6? Watch. 6 over 1 times 10 over 6. The 2 6's cancel out and you're left with 10. So I know that the magic number in order to get from 6 to 10 is going to be multiplying by 10 over 6. So that's the scale factor. That's the conversion factor. So let's convert the XYZ triangle sides into the MNP triangle sides. If I know that 10 over 6 is always going to give me every single side, let's multiply it by the 9 and the 9 over here. So 9 over 1 times 10 over 6 is going to equal to 90 over 6. So I know that this side is equal to 90 over 6. And because MN is equal to NP, I know that this side is also equal to 90 over 6. So all that I did just now was I found the scale factor. I found the conversion factor to get from one side to another. 6 times the magic number is equal to 10. 6 times 10 over 6 is equal to 10. So that's the factor that's going to be true for every single side. In a similar triangle, once you find that one conversion, it's going to be true for every other side on that triangle. That's how similar triangles work. So now I know that MN is 90 over 6. I know that NP is 90 over 6. I know that MP is 10. So they're asking me, what is the perimeter of MNP? So the perimeter is all the sides added up. So it's 90 over 6 plus 90 over 6 plus 10. 90 over 6 plus 90 over 6 is 180 over 6, which is just 30, because 18 divided by 6 is 3, and if you just add a 0 there, you get 30. So 30 plus 10 is equal to 40, which is why the answer to 105 is D. Number 106 says that suppose w, x, and y, and z are integers, none of which are 0. Under which set of conditions would the product x squared yz cubed and the absolute value of w always be positive? So here's the thing. There's some numbers that are always going to be positive no matter what. In this case, the obvious one is going to be the absolute value. An absolute value of a number can never be negative. So it doesn't matter what w is equal to. It doesn't matter if w is positive or if w are negative, okay? That doesn't matter. because it's always going to be positive. W can be negative 1,000. Guess what? The absolute value of negative 1,000 is going to be the positive value of it, which is just going to be 1,000. An absolute value can never be negative. So our answer choice does not need to have W inside of it. We don't need to say that W is positive because anything that W is going to make it positive just because it has this absolute value sign around it. Now here's the thing with x squared. Any number squared is always positive. So it doesn't matter if x is equal to negative 2 or if x is equal to negative 1,000. Why? Because negative 2 squared and negative 1,000 squared are all going to give you positive answers, right? It's always going to be positive. So our answer choices should only really contain answers pertaining to y and z, because y can definitely be negative. Y can be negative just on its own if it's negative 1 or negative 2 or negative 3. Z can be negative because when you cube a negative number, it's still going to be negative. Negative 2 cubed is the same thing as saying negative 2 times negative 2 times negative 2. Negative 2 times 2 is positive 4, but positive 4 times negative 2 is negative 8. So the cube of a number isn't always going to be positive, okay? So based on this, we know that y and z absolutely need to be both positive or both negative in order for this entire thing to be positive. Why? Because if y is negative and z is negative, both of them, a negative times a negative makes it positive, and these guys are automatically positive, which is why choice G has to be the correct answer. Y has to be negative and z has to be negative in order for it to always be positive, okay? It doesn't matter if x is negative because x is always going to be positive because we're squaring it, and it doesn't matter if w is positive because w is always going to be positive. That's why choice G is the correct answer here. Chris has 1 red shirt, 2 white shirts, and 3 black shirts. Chris picks a random shirt without putting the first shirt back. He picks a second shirt at random. What is the probability that the first shirt is black and the second shirt is red? So here we have 1, 2, and 3. So 1 plus 2 plus 3 is going to be 6. So there's 6 shirts in total for us to choose from. And from those 6 shirts, the first one he picks is black. He has 3 black shirts, so the probability is 3 over 6. Next, he doesn't put the shirt back. So because he took one of the black shirts, there's actually 1 red shirt, 2 white shirts, and 2 black shirts left, or a total of 5 shirts left. So what's the probability that the second shirt is red? Well, there's 1 red shirt, so it's going to be 3 over 30, or 1/10, if you divide both sides by 3. 1 over 10. Okay? So number 108 says that Rita used 125 small solid cubes to build a large solid cube, okay? So she's like taking this box and this box and this box and this box and this box, so on and so forth. And when she adds all of them together with 0 space, it actually turns into like a pretty big solid object, okay? So the measure of each edge of the small cubes equals to 1 inch. So each one of these cubes is 1 by 1 by 1. Okay? What is the measure of each edge of the large cube in inches? So we know that volume of a cube is equal to side cubed. So the volume of one of these cubes is just 1 cubed, or 1. Okay? So we know that the volume of each one is 1. And we know that she places all 125 to form one big cube. So if each one of these small cubes has a volume of 1, and there's 125 of them in the shape of another cube, that means that the volume of the big cube has to be 125, right? If I have 2 small cubes together and their volume is both 1, that means that the total volume that they take up is 2. Now, if I arranged 125 of them in the shape of a cube, that volume is also equal to 125 because each cube has a volume of 1. So in the case of this large cube, we know that its side cubed is equal to 125. We know that 5, this looks like a 5, which is kind of a giveaway of the answer because 5 cubed is equal to 125, or choice E. So number 109 says that 5 numbered balls are placed into 2 boxes as shown in the figure above. Davina picks 1 ball at random from box B and places it into box A. Then Yusuf picks 1 ball from box A without looking. What is the probability that Yusuf will pick a ball with an odd number? So here's the thing. There's 2 different probabilities happening here. Davina is picking 1 ball at random from box B. There are 3 balls for her to choose from, so there's 3 total things that could happen, and she's choosing an odd ball. 3, 4, and 5. 3 and 5 are odd numbers, 4 is even. So there's 2 odd balls for her to choose from. So there's a 2/3 chance that what she picks up is odd, and she tosses it here. Notice how in box A, you have the numbers 2 and 6. There are no odd balls here. 0 odd balls here. Nothing there, okay? But what Davina is adding, or what Davina has a 2/3 chance of doing, is she has a 2/3 chance of adding either a 3 or a 5 here. So now she's adding a third ball, which has a 1/3 chance. She's only adding one extra ball, and that one extra ball that she's adding has to be negative. Sorry, it has to be odd. So you have to multiply these two probabilities to get 2/9 as your correct answer, which is A, okay? So again, automatically there's a 2/3 chance that Davina picks up an odd ball, because there's 2 odd balls here out of 3 total. So it's 2/3. Then she's transferring the one ball that she picked into this box. Okay, so there's already a 2/3 chance that she added an odd ball into this box. Okay, so now this box either has a 3 or a 5. So this box has a 1 odd ball in it. So these two probabilities are linked. First, there's a 2/3 chance that she picked an odd ball and put it here. Then there's a 1/3 chance that if this actually happened, if this transfer happened correctly, now there's 1 odd ball out of 3 to choose from. So you have to multiply 2/3 by 1/3 to get choice A. So 110 asks us which graph represents the solution to the absolute value of x plus 1 is greater than or equal to 2. Whenever you're dealing with x plus 1, or a greater than or an absolute value, there's actually 2 possibilities that come from it. Okay? And there's 2 ways to solve from it. So either x plus 1 is greater than or equal to 2. So you split it up into 2 ways, okay? The first way you split it up is just by getting rid of the absolute value signs and keeping it as is, okay? So that's the first method. The first method is just to get rid of x plus 1 inside of those absolute value brackets. And you get that x plus 1 is greater than or equal to 2. The second alternative here, and you can't just do one, you need to do both. The second thing is to make everything else negative. So x plus 1 is greater than or equal to negative 2. Okay? So now you have your answer, right? X plus 1 has to be greater than or equal to 2. So it has to go. So if x plus 1 has to be greater than or equal to 2, solve for x, subtract 1 on both sides, and you know that x has to be greater than or equal to 1. So our number line should have 1 and everything that's greater than that coming from it. Okay? So choice G is out of the running and choice H are out of the running. Now, when we're solving for an absolute value, there's always going to be a second path that we choose, and a second path that's possible, and that's the negative path, okay? Why? Because an absolute value converts a negative into a positive, which means that there's actually 2 values that can make this true, a value of -1 and a value that's going to be negative and a value that's positive. So whenever you break the absolute value sign away, you need to make everything else either positive or negative, right? Why? Because, well, the absolute value of 4 is going to be 4, but the absolute value of -4 is also going to equal to 4. So there's 2 ways for this to be greater than or equal to 2. Either the value that you put inside of it was already positive, which is why we keep this side positive without anything else, or the value inside of this started out negative and ended up positive, which is why, because the value that we put in negative was negative, we have to choose and convert this entire thing, including the sign after this, into something negative, to reflect that possibility that what we put in there was negative to begin with. So because we're making everything negative, that means that our inequality sign also has to change. It's not just -2, the inequality also flips directions to account for the negative change. So that means that x also has to be less than or equal to -3 when we subtract the 1 from that side. So our answer should start at -3 and be less than it, or go in that direction. The only 2 parts of the number line that fulfill my 2 requirements is the number line that's next to choice E. So remember, whenever you want to work with an absolute value, you need to first go through 2 timelines. The first timeline is a positive timeline, right? Where you just put in 4 and you got 4 out. The second timeline is a negative one, where you put a negative number inside of the absolute value, and it outputted a positive value as a result. So we account for the positive version by leaving everything as is and just getting rid of the signs. We account for the negative version by making everything negative. We get rid of the signs, and everything outside of the signs gets turned to negative. So this 2 gets turned to a -2, and this inequality sign gets flipped into the opposite direction. Number 111 says that a rectangular kitchen floor is 12 feet long and 7.5 feet wide. It will be covered completely using new square tiles measuring 0.75 foot on each side. How many tiles will cover the floor? Well, if we want to see how many tiles fit inside of the floor, we first need to find the area of the floor. So we know that the floor is 12 by 7.5 feet, which is written incorrectly. Sorry about that, guys. So we know that it's 12 feet long by 7.5 feet wide, okay? So we know that the area here, 7.5 times 12, is going to be 90. So there's 90 square feet. Keep in mind this is square feet, okay? Now we know that the square tiles each measure 0.75 feet on each side, meaning that they have an area of 9/16, right? Why? Because 0.75 is equal to 3/4, and this is equal to 3/4. 3/4 times 3/4 is equal to 9/16. And remember that this is feet squared. So it's very important that we took the area because we're comparing area to area. We want to know how much space this takes up and how many of these spaces combined will combine and take up 90 feet in total. So now we just divide 90 by the 6/19, by the 9/16 feet squared, right? Remember, keep, change, flip. So we have 90 times 16/9. This 9 turns into a 1. This 90 cancels out into a 10. So you're left with 10 times 16, which is choice D, 160. Moving on to number 112, it says that typically an amusement park sells 3 times as many tickets on Sunday as on any weekday, and 4 times as many tickets on Saturday as on Sunday. If the number of tickets sold on Saturday and Sunday total 30,000, how many tickets are expected to be sold the following Monday? So let's look at this. So let's make another timeline here. So we know that it sells, so here we have Saturday, here we have Sunday, okay? So we know that an amusement park sells 3 times as many tickets on Sunday as on any weekday, and 4 times as many tickets on Saturday as on Sunday. So here we have the amount of tickets that we sold on Sunday, and here we have the amount of tickets that we sold on Saturday. It's going to be 4 times that, so 4 times the amount of tickets we sold on Saturday. And everything after Sunday is called a weekday. So we also know that the amusement park sells 3 times as many tickets on Sunday as any weekday. So if we sell W tickets every single weekday, we know that in order to express this in terms of Sunday, Sunday sells 3 times that, or 3W. And if we know that Saturday is equal to Sunday times 12, that's Sunday times 4, Saturday actually makes 12 times more ticket sellings, or ticket exchanges, than on any other weekday. So if the number of tickets sold on Saturday and Sunday totaled $30,000, if 13W plus 3W is equal to 30,000 tickets, or 15W is equal to 30,000 tickets, we know that W has to equal to 200, or actually 2,000. How many tickets are expected to be sold the following Monday? So I made everything in terms of the weekday. So if I just solve for W, I get 2,000. So 2,000 tickets are expected to be sold on the weekday, okay? This was just a tricky wording, okay? If you look at this as just a regular, this is Sat, Sun, Monday, Tuesday, Wednesday, Thursday, and Friday, right? This is what's considered the weekday, Monday through Friday, okay? We consider these weekdays. And we sell W tickets on each weekday. On Sunday, we sell 3 times as many tickets as on the weekday. So on Sunday, we sell 3 times any weekday ticket, okay? Then on Saturday, we sell 4 times as many tickets as on Sunday. So 4 times 3W is 12W. So now we know that we sold 30,000 tickets on Saturday plus Sunday. That's where I got the 15W from, which is then equal to $30,000. If we divide both sides by 15, we get $2,000 is equal to W. So on every single weekday, we sell 2,000 tickets, so on and so forth. Number 13 says that a rectangular field has a length of 80 meters and a width of 50 meters. The field was recently enlarged, with the length increased by 15% and the width increased by 10 meters. So we know that it has a length of 80 meters and a width of 50 meters. The length was increased by 15%. Okay, so 80 times 15%. 15% of 80 is going to equal to 12. Okay, you just write it out. Just do 8 times 15, add a 0, and then take away 2 decimal points. Okay, so it actually increased by 12 feet. So 80 plus 12 is now equal to our new area, or our new width, of 92. And then we know that the width was increased by 10 meters. So now this is equal to plus 10, which is then our brand new width of 60. Okay, so what percent was the area of the field increased by? Well, originally the area was 80 times 50, which is 4,000. Now our area is going to be 92 times 60, which is actually equal to 5,000 5,500. Oh, let's do this again. 5,520. Okay, but that's not the answer here. We can't just subtract them. We need to find the percent increase. Okay, now percent change is equal to the absolute value of old minus new divided by our old times 100. So in this case, our previous length was 4,000 feet, minus our new length, which was 5,520. We take the absolute value, so we can't get a negative answer, divided by our old, which was 4,000, okay? And we're multiplying everything by 100. So in reality, you're only dividing it by 40. So if you do the math, you take the absolute value of this, you get 1,520, and you're taking 1,520, and you're dividing it by 40, which is going to give you 38, or 38%, which is choice C. That's how you find percent change. It was a pretty simple problem. Just follow the steps. First, find the old area, then find the new dimensions and find the new area, and just plug it into the percent change formula. Number 114 says that if x and y are both negative integers, so an integer is going to be a whole number. So it's a whole number. So it's not 1.5, not negative 1.5. It's either 1 or negative 1, okay? So there's no decimal associated with it. Okay, so if x and y are both negative integers, with x being less than y, which expression has the least value, okay? So we're asking which one of these is going to be the smallest, and we know that they're both negative. If x is less than y, we know that just the value of x is going to be bigger. So for example, x can equal to negative 2, and y, because we know that y is bigger than x, that has to be negative 1, okay? So let's just go off of that assumption. We want the least value, right, to number 1 be negative, and number 2 have the biggest number. What that means is I want to maximize the value, and I also want to make it negative. So here's what I mean by that, okay? Let's say, for example, that I have, instead of it being 1 and 2, I have x is negative 4 and y is negative 3, okay? If I want this to have the least value, I want it to be a negative number that's really big. For example, negative 50 is actually bigger than negative 100. So it's less. So I would want all of these answers to equal to the least possible number. Now notice what's happening here. Your x is always going to have a bigger number here, which means that if you square the x squared is actually going to have a bigger number than y squared. So I want to have my x being squared, not my y being squared. I don't want to square my smaller answer. Next, what I want to do is I want to take my x squared, and I just want to multiply it by y. I don't want to do negative x squared because this would actually give me a positive number. So the correct answer for number 114 would actually have to be E. Now watch this, right? X squared, or negative 4 squared, is equal to 16. And 16 times negative 3 is going to equal to negative 48, which is going to be the smallest possible value, right? Well, what would happen if I squared y? Well, if I squared y, I'd get negative 4 times y squared, which is negative 3 squared, which is 9. I'd get negative 36, which is actually a bigger number than 48. So what you need to notice here is that x will always have a bigger number. Even if it has a smaller value, it is going to have a bigger number. When you square a bigger number, you're going to get a bigger value. And the bigger the negative value, the smaller the bigger the negative number, the smaller the value, okay? The reason why it's not G is because if you square negative 4, you get 16. But because it's not negative x squared, it's negative x squared, there's a negative 1 here, which turns this into negative 16. Now, negative 16 times negative 3 is going to be positive 48, which is actually going to be the biggest value, not the smallest value. So pay attention to these negative signs. Always remember that negative x squared is always going to be positive, but negative x squared is always going to be negative. Okay, so the parentheses matter. This negative is just an imaginary negative 1 times x squared. So it's actually going to make whatever you're squaring turn into a negative number. Either way, this was the entire, all 57 questions from the SHSAT handbook gone over in one video. If you like what you saw, please consider subscribing and liking. If you have any questions as to what I did, please let me know in the comments below. A link to this test and the entire handbook with all the information towards the SHSAT is located also in the description of this video below. And if you want me to go over Form A, which is another test from the same booklet in another video, please let me know as well. Either way, I hope you guys learned something, and I hope this was helpful in your journey to study for the SHSAT. Goodbye.